I think the title alone got this presentation selected. Explosive Shrapnel meets Steel Girders, an expedited inspection and repair. I can't wait to hear this. This is Michael Banasiak from Collins.
Excellent. All right. Thank you, guys. Good afternoon. My name is Mike Banasiak. With me is Dave Crumley from MDT. And if you are wondering what happens when explosive shrapnel encounters steel girders, you've come to the right place. We are the experts. We'll jump right into it. Livingston, Montana, decommissioned railroad bridge over the Yellowstone River. So this is not a scene from Terminator Salvation, as Shane had the example earlier. This is not CGI. This is a real explosion. And we're going to get into the who, what, where, when, and why. But I'd like for you to focus on one thing. So with this explosion, a piece of steel shrapnel was projected out from the railroad bridge to this highway bridge, where it made a bit of a beauty mark on the exterior girder here. And here it is, approximately two square foot, or 2 foot diameter. And at this point, if we don't have your attention now after lunch, we're out of luck here. But for those of you still with us, you're probably all wondering the same question here, and that is, how did we get here? So with that, we're going to flash back in time. I'll turn it over to Dave, who's going to take us back to the Montana floods in June 2022 to kind of set the stage for where we found ourselves. Dave?
Yeah, so how did we get here? How did this bridge project almost literally blow up in our faces? So to do that, we need to go back to the spring of 22 and realize that Montana had a very wet, cold spring. We couldn't buy a nice day above 60 degrees all spring that year. And early June 10th, we had a weather system moving in, and it dropped a lot of warm rain, warm air came in on top of a very deep snowpack for that time of year. It was well above average. The snow tails up on the Beartooth Plateau in Yellowstone Park and the surrounding high elevation mountains indicated that there was anywhere from 1 to 5 inches of rain that was dropped during the storm, and it melted another 1 to 5 inches of snow water equivalent, and that all came out within a couple of days. So kind of to show you kind of how that manifested itself. This is the USGS gauge at Corwin Springs. The Yellowstone River comes out of Yellowstone Park at Gardner, and this gauge is probably 10 or 12 miles north of Gardner. So the gauge has been there well over 100 years. The previous record flood was in 1918. That flood had about a 32,000 CFS flow rate that it measured. It hit about 11.5 feet. A 500-year event at this location is about 37,000 CFS. The event on June 13th hit 53,000 CFS and 13.88 feet. So it blew out of the water the previous flood. So this is the Carbella Trust just downstream from that gauge. It was built in 1918, just after that last flood, and set a foot or two above. I can't remember the exact elevation, but a foot or two above that elevation, that record elevation. This video was taken by a bystander, and the truss just kept tumbling down the river. There are pieces of it sticking out of the river in places now. We're not really sure what's going to happen there, but we do know there's concerned floaters. But one thing that's really interesting for any of you guys or folks that deal with emergencies and failures, take a look at these the end posts here, and we just happened this bystander just happened to catch the buckling of the end post. So kind of interesting to see the actual failure mode there. It didn't actually get swept off the abutments, but those end posts actually buckled. So all that's happening on June 13th. We're kind of getting a lot of, it took everybody surprised in Montana. Nobody really saw this coming. And so we're starting to see things on the news, get indications that roads are closed, things are washed out, nobody really knows what's really going on. So on the 14th, we start getting a little bit more information as far as, this credible from our maintenance folks and the counties about exactly what's happening, where the problem areas are, what's closed. And so on the 14th, we start kind of triaging, trying to decide where we're going to send our resources. So another engineer in the office and myself decided to concentrate on the state structures. We got a list of what we knew had problems and what we thought might have problems, started gathering plans, getting ready to go out in the field the next day. At the same time, we were sending our county guys out or our in-house inspectors out to the county bridges to see what they could find, get us information, kind of there's a lot of places they couldn't get to, but kind of feed us information as best they could. And then in the office, we also had some of the engineers working on a emergency term contract to get divers in the water, because we knew as soon as this water came down, a lot of these bridges, we weren't going to be able to reopen them until we could verify that we had embedment with a lot of our pier footings and abutment footings. So this is the first bridge I showed up to. This is the Pointed Rocks Bridge, actually just downstream from the Carbella Bridge that you just saw disappear into the river. We had a lot of large-scale reconstruction projects going on at the time, and so we suspended time on all of those projects and asked a number of the contractors to start mobilizing into some of these areas we knew we were going to need them immediately. Some of them we had them just start stockpiling rocks for us. Others, we had one down here meet us at this bridge. We scratched out a plan in the dirt to get to start filling this in. What I wanted was to be able to verify that those abutments were still embedded before we allowed them to just continue to fill this whole approach roadway in with rock and whatever. So that took approximately 2 weeks to get it to that right picture where we had everything filled back in and paved and back open to the public. But what's more important is on the 19th, just 5 days after I started this, or the contractor started this and I was there, the divers were actually in the water. The water had receded enough so we could go down and verify that all the piers and the abutments were still embedded. So we were able to open this back up. Another thing to note is we had a lot of stranded people all over the state, especially in Gardner. The Yellowstone Park was evacuated. They couldn't get out for about 3 days. The only other way out of here is a secondary, and it had rock slides and water over the road. And we were able to get that cleared up before we got the main road open here. So while I was at that bridge that afternoon, I got a call from our maintenance chief for the Butte District, and he says the sheriff called and says we think we have another problem. And so I said, okay, I'll be there. We show up. This is what the flood looked like probably a couple of days after I was there. I'm not sure when this was taken, but it wasn't by me. But you can see the water was probably another 2 to 3 feet higher than it is in this video. So you can only imagine, how much water is going through here. During the summer, that pier is in the dry, that railroad pier. So that gives you an idea what's going on there. So we get there. We can see that the railroad structures, a two-span structures built in 1897, abandoned in the early 80s. As far as we know, it could have been abandoned earlier, but we know that MRL, Montana Rail Link, hasn't used it since they've owned it, which was the early 80s. The pier had sunk and started tipping back, and you can see that the abutment on the north truss that's sitting on that pier starting to lose bearing, and you can see the kinks in the tracks there that's from the misalignment that the pier is causing. And so immediately I closed US 89 because when we're looking at this railroad bridge, it's literally 52 feet upstream of our bridge from edge of truss to edge of deck. And so of all the things that could happen, I couldn't think of anything that was good if that truss failed. So this is an overview after the flooding of this area. You can see kind of the alignment of the river, how it makes a 90 degrees and then goes under the railroad bridge and then under the highway bridge. And notice also, I don't know if you can see this cursor, but right here where we were probably within, a few hours of, or so of high water breaching behind through this railroad approach bed. And actually, the river would have then been attacking our approach road on the north side and our abutment and another pier that wasn't scour mitigated. So, So here's simultaneous videos from different directions. One is from the north, one is from the south of the explosion. Kind of notice a lot of debris. You can see it in the water. You can see it flying up and coming back down. This is kind of bringing us back to how we got a hole in our bridge. So we ended up knowing we had to remove this truss, and we didn't want to see it go through another a high water cycle in the next spring. So we actually put together an emergency contract to remove this truss, the railroad trusses. We worked with MRL. They were the owner, but MDT took on all the liability, and we paid for everything. So in the big scheme of things, it's probably the easiest railroad contract we've ever done. So we were able, they said, yep, go ahead, do whatever you want to do. So we let the contract, we awarded the contract, and about a week before the contractor was actually to start work, we got notification that there was, for lack of a better term, kind of a handshake deal between someone high up in Montana and someone in a special forces unit somewhere in the United States, that they were going to show up and do a training demolition of this truss outside of the contract. That threw up a lot of red flags for a lot of people. Needless to say, things proceeded. So within about 4 days, they were doing this demo. And you can only imagine what happened when there's really no oversight and no mitigation, collateral damage plan in place. So once we had this hole, how do we deal with it? MDT has very limited experience with our engineering project managers, our EPMs out in the field, with steel repairs and NDT and anything like that. We have some expertise, but it's limited, and it's not with our field guys. And so with some of the challenges we've had with steel projects before, the idea on this is it's a relatively small scale project. We decided to try to change order the repair into the truss removal. That contractor agreed, said he could do it. Our challenge was, how do we get this moving quickly? So the plan was to come in with a single entity that could go in and do a very thorough initial inspection, do NDT that was necessary, take that information back, scope the repair project out, do the design, and then come back on site, work with our EPM to actually get the repair done and do any NDT and make sure there was continuity between the design and the repair, make sure everything matched up and was done as intended. And so we went through our list of consultants on term contract. Collins had all of the expertise that we were looking for, and they had the availability, and so we put together a term contract, had them out there within days to do the initial inspection, and I guess the rest is kind of up to Mike about how he actually went about getting the repair implemented and designed. So I'll turn it back over to him. So.
Perfect. Yeah, thanks, Dave, for the backstory. Hopefully that kind of takes things full circle to how we got here. So following kind of awarding of a contract, we mobilized an inspection team right away and conducted magnetic particle testing on all suspected areas of impact. As it was, and we confirmed the extents of cracks in the perforation, and also it's worth noting that a lot of the other impact marks and scrapes were superficial. There were no other full penetrations or suspected or confirmed cracks. Also on site, I flew the site with a drone, and in a 30-minute flight, was able to get enough information to create a digital twin of just the exterior girder that we were focused on. And the reason I did this, it was pretty minimal effort in the field, about an hour post-processing in the office, and it would enable our design team and anyone in the office to basically answer any questions they had about the project site, to change up designs or design strategies, because when we were out there inspecting, we weren't exactly sure of what the final repair would look like. So taking this model, gave us information on the surrounding terrain to formulate a jacking plan, and also other details of the girder, splice locations, rivets that we were able to reference in our design. I'll kind of breeze through the design, but it was fairly simple. We ended up on just a bolted splice plate with filler plates. We remobilized our Collins team to the site to observe the repair. And ensure that the contractor was following specifications because it was steel work, and the contractor was originally contracted to remove the truss. So we jacked the bridge, and we were able to maintain traffic on the other side of the bridge. So the bridge was open to traffic during the repair, one lane of traffic. The stiffeners were cut out, and a hole was ground out surrounding the puncture. Plates were cut and fabricated, and also cleaned and primed in the fab shop prior to coming out to site, just like kind of Johnny talked about this morning. We used the plates as a template, and used existing rivet holes for the bolt pattern of the splice plates and fill plates. Made sure to take pretty good caution on grinding out and rounding out, chamfering the corners of the hole, not leaving any stress risers, protecting the bottom flange during removal of the web, and also removal of the rivets. Final kind of plate repair, and observed the tensioning of the bolts. The jack was released, and the bridge was reopened to traffic. The time period from full impact, from the explosion of the bridge to full reopening, and there were some delays in material sourcing, but it was about 4 months, and traffic was able to be maintained on the bridge the entire time, be it just one lane. So this story and project, combined a lot of elements, flooding, scour, NDT, design, and bridge explosions, and really, our main point, was to take you through this story that we found kind of interesting, but also really in conclusion, if you're going to blow a bridge up, make sure you protect the bridge next to it. So if you take home one thing, it'd be that. But thank you very much. We'll take questions.
Any questions? I'm just curious, was there an analysis done prior to the repair to see, just in a temporary nature, how that girder was working in shear with the hole in it?
Yeah, certainly, and we conducted an analysis to ensure proper jacking load, because it was a concern if we jacked too much, we didn't want to disrupt the bearing there. We wanted to take the load off to maintain travel, but not not introduce any external loads, nor raise the bearing of that girder since it was so close. Yeah.
Other questions? Oh, we got one, Doctor.
So it looks like you trimmed the stiffener, and that you also trimmed the bottom angle there. Any decisions that went into that process?
The bottom angle was left. The bottom flange angle was left as is. A filler plate. So there was a fill plate in the middle, and then additional fill plates, so we were able to bolt over the bottom flange. So that was kind of a key decision to leave the bottom flange angles untouched and protected. Tough to see, yeah. The vertical angle was trimmed, and calculations were run on the stiffness of the web, because we took it from one web plate to 5, including the filler plates. That stiffness was adequate. Yeah, thank you. Good question.
Okay, thanks, guys.
Cool, thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.